All right, good morning. Thank you. Yes, it's a pleasure to introduce actually a brand new company, Just Breathe Free. And I'm going to start out by showing the team. This is relatively new company, new technology. And so as you can tell, we're in the very early stages. But we have Katie Bertel and Megan Donnert, who are the drivers of the company, really, and they represent sciences, engineering, and business. And so myself and Gabe Garcia, we're the folks that have patented the technology, the initial patent of the technology at New Mexico State University. And when combined, we have over 60 years of experience in research and development, in mechanics, and drawings and fabrication, as well as in particle analysis and developing devices based on particles. Jens Elze and Augie Fitzpatrick, or Noel Fitzpatrick, are part of our advisory board. And Jens is an expert in his company in terms of power electronics, and Apex Microtech develops power electronics for the medical industry, as well as a variety of industries in Tucson, Arizona. Augie is an entrepreneur, chemist, and Augie and I developed some inhaler technology a few years back that's under FDA approval process. So he's also agreed to be on our advisory board. So at this point, again, we just got started and we're using a $50,000 research initiation fund at New Mexico State. And we're in the process right now. We have a private foundation, a donor that is finalizing a commitment of $150,000 to develop the technology, primarily for international markets. And I'll explain what the innovation is. So hopefully you can see it. I think it's a little bit clipped, so I'm going to get out of presentation mode so that you can see it a little bit better, hopefully. But the idea behind this is a new idea on something that you've probably heard a lot about the past year, which is a technology for personal protection, but it has a bit of a difference that makes it stand out compared to others. And I'll explain that in more detail. But the basic idea here is that it's a technology that's combining physical barrier with an electronic barrier in a new way. And the electronic barrier is the focus of most of what I'll be explaining, but it's a very important tandem with the physical barrier. The electronic barrier is the production of ions in a fashion that makes it work really well in this application. And so just a chart is given there to explain how this is a naturally occurring situation in terms of negative ions. But in the case of this particular technology, we have 100 million ions per cubic centimeter is the goal and the target as to what the technology can produce. So in the next slide, again, it's clipped, so I'm gonna move it out for a minute. But just so you can see some of the words, and then I'll show the full slide. What this is about is directly related to how to form a face covering technology that can really make a difference in terms of public health. So mask wearing, obviously, and in general, respiration devices of a variety of kinds have been used in medical applications. And now in the general public is very aware of these. But our goal here and the goal of this company is to develop this generation of technology that'll do a variety of things. And so as you can see, the key idea in terms of the standard product, if you will, is that we would like to have this electronic barrier in combination with a lightweight, easy to wear, clear plastic physical barrier so that you can communicate and you can have an easy time wearing it for long periods of time. And it's a very low powered device. And I'll explain that a little bit in a couple of slides, so that it can be worn for many hours. And with battery power, it could last for up to 2 days. So, so it's really designed for that. Now, the key thing here, and I guess the key cognitive thing I wanted to show is this movie. So this movie on the little animation, I guess, on the left-hand side may look a little odd, which it should look a little odd because it's being run in reverse. So most of us think about personal protective equipment in the sense of protecting ourselves or the wearer, I guess. Here, this is doing both at the same time. So not only is it protecting the wearer because of this physical and electronic barrier, but the electronic barrier provides an opportunity to make sure that, as compared to some other technologies, people that are breathing out pathogens of any kind will also be able to protect those people in the room. And the applications of it could be done so that multiple wearers in a particular room actually have a combined effect. So we're looking initially at what kinds of solutions would be best for this kind of technology. And the flexible design is one area that is another part of this is unique. So the electronic barrier and the physical barrier don't have to go together. The physical barrier can be replaced by others without really affecting the overall product desirability, I guess, if that's the case in putting it that way. But the clear plastic barrier, we think, is going to be really important as a solution for people that want to be able to communicate and others to see their faces. So in the next slide, hopefully you can see most of it, is that this market is not just for our current situation. So we believe, based on the fact that we know of a number of respiratory situations, especially the flu, for example, but there are over a couple of dozen known pathogens that are airborne, microbial and viral, that now with our situation, people are more attuned and more aware of the need for additional protections, even post our current pandemic. So we're focusing in this company on targets that are of interest in this particular region, which is education and agriculture. So that's our initial focus, and that's what the newly formed company is going to be pursuing in terms of its market strategy. The other part about this that I want to emphasize is that the technology is based on a different paradigm from the previous mask technologies. The mask technologies currently, because of the need for either a really good physical barrier, create a situation in terms of fitting the mask, as we all know, as well as the cost and complexity. Those that employ air purification systems suffer a lot from power problems. And so after we spent the last few months going over hundreds of different designs and patents, and that's really been the focus of most of the air purifiers, is the limitations on either the air leaving the person wearing the mask or suffer from battery, just because battery life, because of the power needed to move air around. And so in our—
Tony, you have a minute left.
So our results are here, and I'm pretty much done. This gives you an idea of the different types of testing. We've moved into looking at particle image velocimetry in our laboratories, and we're getting good results to show how this works in tandem with a face covering, a cloth mask, or a surgical mask. And the device is also designed with keeping in mind safety, so it doesn't generate ozone above a suitable level. It's a very, very low level of ozone generation. And so our next steps is to move on to field testing. And as I mentioned before, we also just started writing grant proposals and developing visualization tools. So thank you for your time.
Thank you. Questions, Ben and Andrew?
You're on mute, Ben.
Sorry about that. Thank you, Tony.
Okay, thank you.
Is the reason why you're going after education and that first just for the proximity of development and testing?
Yeah, we think that starting with that market is one that would be closer to where we're looking to target. We're also hoping to partner with a PPE provider or a company that's in this area, so that we can envision ourselves being more of a product geared towards a specific market like education and agriculture.
Okay, and then have you developed a prototype already?
Yeah, we have several generations of prototypes. That last picture I showed was my wearing one of the prototypes. So I guess I can put that back up real quickly.
So that is a working prototype.
Yeah, it's a working prototype. So that was on a Zoom meeting. Right now, the face covering, we're designing it so that the physical barrier, so that it's lighter weight. And then I'm wearing, it's hard to see it, but I'm wearing the electronic component to it. And so that is
Where are the electronics?
The electronics are power electronics. They're ion generator modules, and we've designed them in a way that utilizes the body as part of the circuitry to improve the performance and the uniform distribution of ions.
Okay.
Great. Tony, thanks for sharing that with us. Very interesting presentation. I guess thinking about competition, it can come in many different ways, more than just masks and others out there. Can you talk about how you're going to be able to communicate the value proposition versus somebody just putting in air conditioning or air purification system in an entire room that would have an air ionizer in it to be able to do that on a larger scale than on an individual basis?
Yeah, we thought about that. One of the problems with buildings that have those systems is when a person comes in from the outside, there's a lag time in that room or that building. And if the person is already spreading particles around, there's anything from minutes to perhaps longer. So in the idea here, you have a facility or you have a group of people that are wearing them, and as they move around, they are taking the purification with them.
Got it. Thanks.
Have you done any testing on results with your system versus just wearing an N95 mask?
Yeah, we combined with N95 and we see an improvement. The ion barriers will create a situation where, depending on the type of mask, you still have very small particles that can exit through. So it will capture just a few percent that are exiting the mask as well. And the ions can penetrate through the fabric because they're the size difference, obviously. So we've measured that the ions can actually get into the other side of the fabric material. So they are kind of through the process, you can generate ions that are around the mask area and also that are actually closer to the person's face even.
And what do you imagine the unit economics are going to be for something like this? What is it going to cost to manufacture, and what do you anticipate to sell at?
We intend that our target for it to be successful would be somewhere an introductory price below $100, which we think is possible based on the electronics that are out there and the fabrication of the clear plastic barrier. We think with accessories, with particle detectors or accessorizing the material, even with a performance sensor, we think we can keep to that price point.
Okay, we have about 30 seconds left. So does anybody have one last question?
Is there a useful life for the mask?
I'm sorry, useful life? The electronics part should last until there's some problem with it in terms of potentially misuse. But the plastic face covering, we think to make it as lightweight as possible, or we can have it disposable depending on the comfort factor. So we think it could be reused and cleaned maybe a couple of years.
Okay, thank you.
Thank you, Tony.